Hello viewers, I am Dr. Uday Maji, faculty of Applied Electronic Instrumentation Department. Today I am going to discuss on digital topic called sequential circuit design. As we know that digital circuits mainly of two types. One comes under combinational circuit and another is sequential circuit. The basic differences between the two: in case of combinational circuit, we haven't observed any kind of feedback from the output to the input, whereas in case of sequential circuit design, we observe there are some output taken from the feedbacks taken from the output to the input. That's why output of the circuit at any time doesn't depend not only on the present input but also it depends on the past state as well. So based on this, today I am going to cover the topic sequential circuit design. To discuss about the output and how to draw the state diagram and state table of a given sequential circuit, I have taken one example which consists of two D flip-flop and few gates. If we observe the D flip-flop outputs in the form of A and B, it depends on the given input X as well as previous step of the same flip-flops. So to find out the next state expression, here we can observe that first D flip-flop input is given from the previous state A and the input X as well as previous state B of the second flip-flop. Here we can write the output of this AND gate is AX. Similarly, output of this AND gate is BX. So the OR gate output will be AX plus BX. Hence, the output of the D flip-flop, that is the next state A, will be AX plus BX, as we know that D flip-flop output directly depend on its input only. When the clock is applied, the same will be available at the output terminal. So the next state expression AT plus 1 will be equals to the present state AT dot X present state BT dot X. Similarly, to observe the output of the second D flip-flop, we can find that its inputs is given from the complement of the first D flip-flop state, that is the A bar, and the input X. So the input of the second D flip-flop is A complement dot X. So same way, BT plus 1, that is the next state of second flip-flop, will be equals to A complement dot X. There is another output also present in the circuit. It depends on the present state B, A and the given input X. And from this circuit we can write that output Y will be equals to A plus B, as the OR gate output is A plus B and ultimate output Y from the AND gate will be equals to A plus B dot X complement. After observing the state of the D flip-flop and the output Y, next let us find out the state table of this given circuit. To draw the state table, we have to write it in the form of present state, next state, as well as output in the form of Y. As the input is X, so the circuit output depend not only on the A and B present state but also the X as well. So two columns is prepared, one if X equals to 0 and another one if X equals to 1. So from the equation we can observe that output equation at plus 1 is equal to btx plus a t plus 1 is equal to a t x plus b t x. So if the input x equals to 0, if the input x equals to 0, then the next state will also be equals to 0, no matter what is the present state at and bt. So here we can write the next state at plus 1 equals to 0 if x input equals to 0. Similarly, next state bt plus 1 is given by a complement x so here also if the input x equals to 0, then next state bt plus 1 will also be equals to 0. So we can write here next state bt plus 1 equals to 0 if x equals to 0. Now let's find out what will be the next state if x equals to 1. From the equation, if x equals to 1, it comes at at plus bt only. So if at and bt both are 0 0, then only at plus 1 will be equals to 0. Otherwise, for any other condition of present state at or bt, it will give us the output equals to 1. So when at and bt equals to 0 0, then only the at plus 1 equals to 0. Otherwise, for any other situation, at plus 1 will be equals to 1. Similarly, in case of bt plus 1, that is the next state of the next second flip-flop, will be equals to 1 if a equals to 0, as because it depends on the a complement. If x equals to 1, then we can write bt plus 1 is equal to a complement only. So when a equals to 0, bt plus 1 will be equals to 1, and when a equals to 1, bt plus 1 will be equals to 0. So let's write bt plus 1 as for the first situation a equals to 0, so bt plus 1 equals to 1. Second situation at equals to 0, so bt plus 1 equals to 1. Third situation at equals to 1, so the bt plus 1 equals to 0, and similarly for the fourth. So hence we have observed that the next state for the different input value x and x equals to 0 and x equals to 1. Similarly, if we want to observe the output y of this circuit, as it depends on a plus bx bar, a plus b x complement. Hence, if x equals to 1, y will be equals to 0. If x equals to 1, y will be equals to 0. So output for x equals to 1 will be equals to 0. No matter what is the state a and b. If x equals to 0, then y will be equals to the state a plus b only. So in that case, we can write for first situation a0 b0, a0 b0 will equals to 0, a0 b1 output 1, A1 B0 output 1, and A1 B1 output equals to 1. So this is the state table of that circuit. Similarly, from this state table, if we want to draw the state diagram, as we observe, as we know, seen that there are 2 flip-flops, so there will be 4 different states. There could be 4 different states. It could be 0 0, it could be 0 1, it could be 1 0, or it could be 1 1. Based on this, we can prepare the state table when the input equals to 0 and when the input equals to 1. To prepare the state table, we can draw it in this way. First of all, we need to write the different states. With 0 0, then 0 1, then let's write 1 1. As in the table we can observe, state is changing in the fashion first 0 0, and from 0 1 it is changing to 0 0, it is changing to 0 1, and from 0 1 it is changing to 1 1. So here I have written as 0 0 0 1 1 1, and finally from 1 1 to 1 0. So when state is changed, transit from 0 0 to 0 1. Now to prepare this complete structure, let's observe the state table. So firstly, we can observe that if x input equals to 0 and clock is applied, then it will remain at the same state from 0 0 to 0 0. So we have to draw it in this fashion. And on the arrow, we have to indicate that x input equals to 0. And at the same time, what is the output? Y. At that point, output y equals to 0. So slash 0. First digit indicates the input to the circuit, and second digit indicates the output of the circuit. So at the first situation, when 0 0 is the present state and x input equals to 0, it will not changing its state and remain at 0 0 only. At the next situation, if we observe that if x input is equal to 1, the state is changing from 0 0 to 0 1. So state is changing from 0 0 to 0 1 when input is applied as 1. Input x equals to 1. And at the same time, what is the output you are observing for x equals to 1? Now it is 0. So slash 0. For the input x equals to 1, out state is changing from 0 0 to 0 1, and output equals to 0. Next, if the present state is 0 1 and input x equals to 0, then you can observe that again it is not changing the state. So for this situation, when x input equals to 0, the system or circuit out state will not change, it will remain at the same position 0 0 0 1. And at that time, what is the output? Now output we can observe as x equals to 0, output equals to 1. So at the left side of this, it is presenting the input slash, at the right side it is presenting the output y of the circuit. Here it also observed that in case of applied input x equals to 1, the state is changing from 0 1 to 1 1. So when input equals x equals to 1, state is changing from 0 1 to 1 1, and at that time what is the output of the circuit? Output equals to 0. Next, when the state is at 1 1, when the state is at 1 1, applied input x equals to 0, then when the present state equals to 1 1 and x input equals to 0, it will change to state will change to 0 0. State will change to 0 0 at the situation when input is given as 0. And you can also observe that in case of x equals to 1, state changes from 1 1 to 1 0. In previous state, when x input equals to 0, output was 1, and similarly in case of x input equals to 1, output equals to 0. Next, if we observe that if the present state equals to 1 0, similarly if the input is applied as x equals to 0, it will change to again 0 0. So and at this situation the output equals to 1. And we can observe that if present state equals to 1 0 and for the given input x equals to 1, the state is not changing. So in case of given input x equals to 1, state is not changing, it will remain at the 1 0 state, and in this situation the output equals to 0. So this is the overall state diagram of the circuit is presented here, the phase diagram. So that's how we need to first write the state table from the given sequential circuit, then the state diagram. Next, let us discuss how to design one sequential circuit if the state diagram is given. Here I have taken one state diagram like previous one, as it can be observed that state is changing from 0 0 to 0 1, 0 1 to 1 0 and 1 0 to 1 1 when the input is applied 0 1 or 1 0. This time it can be observed that on arrow single digit is present, the next part is absent. That means this circuit, other than the state output, no separate output Y is available, but the input X is given, and based on the given input X and the present state, the state is changing from 0 0 to 0 1, 0 1 to 1 0, 1 0 to 1 1. As in this diagram, state is presented by 2 digit 0 0 or 0 1. Hence, to design this circuit we require 2 flip-flops. In this particular problem, no specific flip-flop is asked to design. So for designing this circuit, I will be discussing with the help of JK flip-flop. So to start with, let us first prepare the present state and next state table based on the given input. Primarily concentrate up to this part first. So here we have taken different states A, B, 0 0, 0 1, 1 0, etc. and the input X. So when x equals to 0, first we can observe that state is changing. So it remain at 0 0 to 0 0 as the previous state diagram shows. When x input equals to 0, it remain at the same state 0 0, but when one input x is given as 1, it is changing from 0 0 to 0 1. And here, if the x input equals to 1, it is not changing the state, whereas if x input equals to 0, the state is changing from 0 1 to 1 0. So based on this information, this whole present state next state table is prepared. 0 0 to 0 0, 0 0 to 0 1, and up to if the state equals to 1 1, for the given input 1, the state is changing to 0 0. After preparing this present state next state table, we have to prepare one excitation table with which we need to design the circuit. This circuit will be designed for this particular case by using JK flip-flop, as 2 flip-flop is required. Here the excitation in excitation table, it is named as JA KA and JB KB. Here we need to find out how we should excite the JK flip-flop, so that if the present state is given to us and after application of the input, specific input x equals to 0 or 1, we can obtain the next state. Accordingly, we have to specify the excitation input. From the excitation input table of the JK flip-flop, we can derive this, that is, if the present state of A equals to 0 and next state also we need 0, then we have to apply the input terminal of JK flip-flop as equals to J equals to 0 and K equals to don't care. That means it could be 0 or 1. Next, here it can be observed that it is present state 0 and next state also 0. So excitation input remains same. For the third situation, it can be observed that the present state is 0 and next state 1. That's why the excitation input is changed from the previous to J should be equals to 1 and K should be equals, K maybe don't care, either 0 or 1. So accordingly, J and K of first flip-flop excitation table is prepared. Similarly, observing the present state and next state situation, of B, we have to prepare the excitation input of the second flip-flop. Here the input terminal is named as JB and KB. So like previous situation, present state is 0, next state is also 0, so it is 0 don't care. Present state is 0, next state is 1, so it is 1 don't care. Accordingly, whole table or whole excitation input is prepared. After completion of this table, we have to prepare the right combinational circuit or equation for the excitation input J, A and K based on the present state which is available to us and the input given to the circuit. We need to find out the equation for JA, KA, JB and KB based on the present state A and B and the given input X. By using Carnot map, we can easily find out the equation for JA, KA or JB and KB considering A, present state A, present state B and input X as input to the circuit, and JA or KA, JB or KB as the output. So it will be a 3 variable Carnot map. By using 3 variable Carnot map process, we can obtain the equation for all these 4 excitation input. Here is the presentation of that Carnot map. This is the equation or mapping of the A, B and X considering as input and JA as the output. We observe that the equation of JA will be BX complement. Similarly, KA equation will be BX. JB equation will be x only, and KB equation is A x naught x. So once we obtain the equation for all the excitation input of the JK flip-flops, then we can easily draw the circuit in the form. Here there is the first flip-flop whose inputs are JA and KA, and second flip-flop whose inputs are JB and KB. This circuit is completely formed based on the available equation in the previous step. So once we get the equation, then easily this circuit can be drawn, and this is the ultimate presentation or ultimate circuit for the given sequential problem. Hence, if this kind of state diagram is given to us, by following the proper step with the given JK, with the given flip-flop, we can find out the corresponding circuit. In this particular circuit, one thing is missing, that is the output Y. If it is also given or present in the state diagram, then additionally we need to find out the output equation by using Carnot map itself, and we can draw the whole circuit not only with the states A, B, etc., but also with the additionally output Y. So with this, I conclude my discussion here. Thank you.